The purpose and need is a very important part of environmental documents. And so I'm going to focus on some of the highlights and information that's included in a purpose and need statement within a environmental document. In particular, this is part of an environmental assessment, so an EA document. And this is for a project I-440 around the city of Raleigh, North Carolina. And so this is the segment that's being improved. It's in Wake County. It has a state transportation improvement project number. The estimated cost is approximately $500 million, $475 million, with a start of fall 2019 and an expected completion date of the summer of 2023. So the overall need, and so this is where we're getting into the need and the purpose. So the agency needs to document that there is a need and that there's a purpose for the project, because ultimately if we're going to expend public funds and have an impact on the human and natural environment, there should be some need and purpose for that project. So this is a 4-lane section of an interstate highway. It's a loop around Raleigh, or really kind of a bypass, because it only goes on the northern section of Raleigh, leaving I-40 and then reconnecting with I-40. And this is known as a capacity deficiency area, where there's a 4-lane section that connects to 6-lane sections to the north and the south. There are also geometric deficiencies for the roadway and interchanges in the study area that have substandard design elements. And in particular, this example, I think, does a great job of explaining where those deficiencies are and what those deficiencies are, so their location and their actual extent of those deficiencies, as well as there's condition deficiencies, including the pavement, structures, and interchanges that are in need of rehabilitation. So this location not only has capacity issues, but there's things that need to be upgraded anyway, and so that's building into this purpose and need of this project. So some of the supporting documentation, this table shows us the 2012 traffic volumes and the 2035 expected traffic volumes and the percent change. So there are current capacity issues, and it's only going to continue, or expected to continue, to get worse. Looking at this in terms of level of service, on the left we have 2012, the existing data, and then in 2035 on the right is the future in a no-build scenario. So how bad is it going to get if nothing is done, if the project isn't completed? This is the peak 1 hour in both the northbound and southbound directions for the various segments of the project. And you can see red is bad, so as you move from 2012 to 2035, if no improvements are made in that peak hour, AM and PM, there's a lot more red in that 2035 time frame. So level of service is expected to decrease over that time horizon. We can also look at crash rates, and the ones that are shown in bold are where the actual crash rate is above average, far enough that there's a crash issue, and these are for any values that are less than 1. And so these are these crash types and overall. So overall there is a crash problem. The actual crash rate is 324. And this is per 100 million vehicle miles traveled. So that's our rate here. For other North Carolina urban interstates, it's 101.82. And if we look at the critical crash rate, it's 117. And so we can divide the critical crash rate by the actual, and that's what the safety ratio is. And so that's why overall we have a lot more crashes than what we would expect. So it indicates that there is a statistically significant crash problem. It's not necessarily that way for fatal crashes, and likely that's due to lower speeds because of the level of congestion that's there, but there is a higher than expected amount of non-fatal injuries, crashes, nighttime crashes, and wet condition crashes. So there are crash issues at this location as well. And now digging into some of the additional details that are provided. So this is looking at basically a parcel map that is just orienting us to the project, showing us where we're connecting. And so there's 6-lane segments on each side of this. And this is the 4-lane cross section that is present. So just to again reorient us to what we're looking at, and I'm going to show a series of images and figures that are presented in this purpose and need document to help build that case that there's a purpose and a need for this project. So this shows us the lane configuration, so we can see there are some auxiliary lanes along the corridor. For the most part, it's 2 lanes in each direction, but in some cases between the interchanges there will be an auxiliary through lane that connects those interchanges. We can also see this one shows us some of the design characteristics of the bridges and entrance and exits, horizontal clearance, decision site distance. So in particular, looking in a little more closely, red is bad, the blue is fair condition. So at this ramp here, so this loop ramp is red, so that means that the entrance, or in this case the exit loop, is deficient. Similar on the other quadrant here, this entrance loop is deficient, and so any place we see red, there's some deficiency issues. We have horizontal clearance issues at these bridges, so I-440 going underneath these bridges has some clearance issues there. We can also look at decision site distance. That's a type of site distance that we want to provide to drivers to make appropriate decisions. Those are used by these symbols. So this is showing us these are areas of deficient site distance. And then we also have some bridge information in here. So here's an example of a bridge that's in poor condition, likely in need of some improvement. And so as part of upgrading this overall project, we're going to have the ability to address some of these deficiencies. This is looking at the traffic volumes. So as we move along the corridor, we're seeing the actual traffic volumes. The top number is the 2012 traffic volume, and the bottom number is the 2035. So for example, we can look at this part of this segment of the corridor. So we have 81,200 vehicles in 2012, and we expect by 2035 for that segment to have 98,700 vehicles. So substantial traffic volume there. Here's another image just showing us some of the land uses. So it's important to think about what's the purpose of the project, what's it connecting. This is in the area of a couple of college campuses, North Carolina State University and Meredith College. We can see over here on the right side, we also see some retail and office parks. Into the bottom left part of the corridor, there's some sports and entertainment facilities, including the state fairgrounds, an arena that's used for college basketball and professional hockey, and a football stadium as well included. And there's also the North Carolina Museum of Art and a hospital that's all within proximity to this corridor. So a lot of different land uses that attract and generate traffic. And I thought this was a really clever way to show the existing conditions. So there's several different things shown here. So P is for physical condition, G is for geometric features. We have design operations and operational performance, and we have these for both the southbound direction of I-440 and the northbound direction. So similar type information shown for each direction. And we have good, fair, and poor are our categories here. So we can look at the structures, so we can see where they're located along the corridor. So this is giving us distance along the corridor. And we see we do have a couple of structures that are in poor condition, one in fair condition. The pavement in this section is in poor condition throughout. We can look at the geometric features, and for the most part these are green, indicating good geometric features, but we do see there's issues with horizontal clearance here that we talked about previously, decision site distance, and again we can see exactly where these are occurring, entrance and exit ramp design. The design operations, including route continuity, lane balance, and ramp sequence, are overall good in this area. And we can look at operational performance. The level of service on the main line is poor. We see that throughout the corridor, level of service E and F. The safety ratio does have some sections that are in good condition and some that are in poor condition or poor safety performance. So these are just, again, different ways of presenting information, building that case that there's a purpose and a need for this project.